Okay, guys, today we're going to look at concept number 4, which is calculating the molar mass of a compound. So what is the molar mass of the compound? The molar mass of the compound is the total mass of 1 mole of that compound. The best way to explain that is to look at an example problem. So let's do example number 1, which is calculate the molar mass of NaBr. The first thing you need to do is figure out what are the elements that are in that compound. So for this compound, the two elements that are in it are Na and Br. The next thing you're going to need to do is you're going to need to determine the mass of just the Na and the mass of just the Br. So you're going to need your periodic table, and you'll need the value for the atomic mass of sodium, and as well you'll need the atomic mass of bromine. So let's start this off. When you're looking at NaBr, you need to determine the amount of atoms of Na and Br that there are, and then multiply that number by the atomic mass of that atom. So for Na, we have 1 Na times the mass of that Na, which is 22.9 grams, and that's going to be equal to 22.9 grams. That's the mass of just the sodium in sodium bromide. Let's look at bromine. Bromine, there's only one bromine in NaBr, and that has a mass of 79.9. So you're going to take 1 times 79.9, and that's going to be equal to 79.9 grams. That's the mass, again, of just the bromine. Now what you're going to have to do is you're going to have to add those two up. So you want the total mass of the compound. So the total molar mass of NaBr would be the mass of each of the elements added together. So we're going to take the molar mass of the one sodium atom plus the molar mass of the one bromine atom, and we are going to get the total molar mass of NaBr to equal 102.9, and we always need to have units with these numbers. So since this is the total mass of 1 mole of a compound, the unit for the molar mass is grams per mole. Let's look at a second problem. A second problem would be the molar mass of PbSO4, or lead 2 sulfate. Again, you need to separate out and figure out what are the elements that are in this compound. So in this compound, we have Pb, we have S, and we have O. Now, we need to look at our periodic table again because we're going to need the mass of lead, sulfur, and oxygen. So you're going to need all of these values. So get out your periodic table again and look for the mass of lead, the mass of sulfur, and the mass of oxygen. The next step we need to do is we need to figure out how many lead, sulfur, and oxygen atoms we have, and then figure out the masses for each of those. So let's start with lead. In the formula PbSO4, you have 1 Pb, and we're going to multiply it by the mass of that lead atom, which is 207.20 grams. And that's going to give us the mass of the one lead, which was 207.20 grams. Sulfur also has one atom, and the mass of sulfur is 32.06 grams. So when we multiply 1 times 32.06, we get 32.06 grams of sulfur. Oxygen, however, has 4 atoms, and you're going to have to multiply it by the mass of oxygen, which is 16.0. When you do that, you get 64 grams. Again, these masses, 207.20, 32.06, and 64.0, are the masses of the individual elements. We want to know what the molar mass of the compound is. So to get the molar mass of the compound, we're going to have to add the mass of lead plus the mass of sulfur plus the mass of oxygen. And when we do that, we get a molar mass of PbSO4 to be 303.3. And remember, this is a naked number as of right now. We need a unit. And molar masses are the amount of grams per 1 mole of that substance. Now what I want you to do is to go to your student success packet, and I want you to complete the next few practice problems so that you can get more practice with calculating the molar masses of different compounds.